Hello everyone, welcome to the new session of Introduction to Agrometrology. This is the second part of this, we can say, to the agrometrology, and in this second part we are going to study about the structure of Earth atmosphere. So whatever the phenomena is taking place in the Earth atmosphere, like rainfall, humidity, rise of the temperature, lower of the temperature, sunshine reaching to the Earth's surface. Okay, so all these phenomena taking place from the Earth atmosphere only. So it is very important to understand this part of the chapter. Moving forward. Okay, so structure of the Earth atmosphere. So if we see the figure, then we can see the atmosphere can be divided into certain layer, right? So the first one is the troposphere. Second is the stratosphere. Next is third one, mesosphere. And fourth one is thermosphere. Above this, there is one more layer. This is called as exosphere. Okay, so we are going to study all these layers one by one. We will try to understand what are the phenomena which takes place in these layers. Okay, yes, the first one is the troposphere. So the troposphere is the lowermost layer, very important, lowermost layer of the atmosphere, and makes up about 75 to 80% of the Earth atmosphere. So this is the major part of our Earth atmosphere, that is troposphere. Very important to remember this, that our 75 to 80% of the Earth atmosphere is made up of troposphere. The average height of this layer, lowermost layer of the atmosphere, is about 14 kilometer above the mean sea level. So if we record what will be the height of the troposphere, so it will be around 14 kilometer from the mean sea level. This is 14 kilometer, right? So at the equator it is 16 kilometer and 7 to 8 kilometer at the poles. Okay, so troposphere is not we can say that it is not unanimous all over the surface of the Earth. Okay, at the mean sea level it is 14, at the equator it is around 16, at the poles it is 7 to 8. So these points are very important to remember. Okay, but this is the most important, that 75 to 80% of the Earth atmosphere is made up of the troposphere. Next point. In this layer of the atmosphere, all weather phenomena occur. So question can be asked in the examination in the form of MCQ, that in which of the layer of the atmosphere weather phenomena takes place. So weather phenomena takes place in the troposphere layer, right? The higher we go up to the troposphere, the colder it gets. So as you move upward from the surface of the Earth, you feel colder. So why? Because the sunshine or the light, which is also having the heat part of the sunshine, is reaching to the surface of the Earth, right? But it is colder as we move above. So the air is also gets thinner as we travel upward. Very important. Air is thinner as we move upward. Right? So in the troposphere, because nearly all the water vapor and dust particles of the atmosphere are in the troposphere layer. So major water vapor, dust particles and the air are present in these layers at the lower surface of the troposphere. So as you move above the surface of the troposphere, right, so air will get thinner, right? Under normal condition, the height of the troposphere changes from place to place and season to season. This is changing the height of the troposphere according to the season, according to the place, right? So various types of clouds, thunderstorm, cyclone, anticyclone occur in this sphere because of the concentration of almost all water vapor and aerosols in it. So this layer is called as seat of weather phenomena. Again, there is a question that in which of the layer of the atmosphere seat of weather phenomena is called, or seat of weather phenomena takes place. Okay, so it occur in the troposphere. Okay, and why it occur? Because the major concentration of water vapor and aerosols in this layer of the atmosphere, right? Wind velocities increases with the height and attain a maximum at the top of this layer. Another striking feature of the troposphere is that there is a decrease of temperature. There is a decrease of temperature with increase in elevation. So as you move upward, there is a decrease of temperature in the troposphere. Okay, at a mean lapse rate of about 6.5 degrees centigrade per kilometer. So as you move above the troposphere layer, every kilometer there is a drop of 6.5 degrees centigrade, okay, of the temperature. Most of the radiation received from the sun is absorbed by the earth's surface. So all the radiation, it reaches to the earth's surface. All the radiations reaches to the earth's surface, and this particular surface, the earth's surface, get heated. It get heated. So the troposphere is heated from below. At the upper layer of the troposphere, the heat is less, okay, or it is cooler as we compare to the lower surface of the troposphere, right? So in this layer, about 75% of the total gases and most of the moisture and dust particles are present. So all the 75% of the total gas as well as the dust and moisture part is present in this particular region of the atmosphere. Okay. At the top of the troposphere, there is a shallow layer, there is a thin layer, or we can say a shallow layer separating it from the stratosphere, which is known as tropopause. Very, very important. So we are having troposphere, we are having stratosphere, and in between this there is a thin layer of a troposphere which is called as tropopause. The tropopause layer is thin and its height changes according to the latitudes, and it is a transitional zone. This is the transitional zone between the stratosphere and troposphere, and distinctly characterized by no major movement of air. Very, very important. No major movement of air is occur between in the tropopause. Next layer, stratosphere. It is the second lowermost layer of the Earth atmosphere. So as we move from troposphere, there is a second layer that is called as stratosphere. In between the stratosphere and troposphere, there is a thin layer that is called as tropopause. So it lies above the troposphere and it is separated from it by the tropopause region. This layer extends from the top of the troposphere at roughly 12 km above the Earth's surface to the stratopause and an altitude of about 50 to 55 kilometers. Okay, so this is the region. This is the region of stratosphere. This is the region of stratosphere, above the tropopause. Okay, so it is roughly 12 kilometer above the Earth's surface. So it started from 12 kilometer roughly. Okay, and at an altitude of about 50 to 55 kilometer above here. So this is called a seat of photochemical reaction. Okay, so troposphere is the seat of atmospheric phenomena to take place, but the stratosphere is a seat of photochemical reaction. So lot of chemical reaction takes place in the atmosphere due to the photo means light. Chemical reaction takes place, right? So that is why it is called as seat of photochemical reactions. The temperature remains practically constant at around 20 kilometer, and it is characterized by the isothermal because air is thin, clear, cold and dry near the tropopause. So near about the 20 kilometer of the Earth atmosphere, it is an isothermal because the temperature is practically same, no changing in this region of the temperature. Okay, so the temperature of this layer increases with the height and depends upon the troposphere because the troposphere is higher at the equator than at the poles. So heating of the atmosphere is totally because of the layer of the Earth's surface. It is not because of the any atmospheric layer. It is because of the Earth's surface get heated when radiations reaches to the Earth's surface, right? Okay, now this is very important. In the upper parts of the stratosphere, the temperature are almost as high as those near the Earth's surface. Now here the temperature is quite high, which is due to the fact that ultraviolet radiation from the sun is absorbed by the ozone in this region. So why it is higher as the surface of the Earth? Okay, the temperature is as high as the Earth's surface because there is an absorption of the ultraviolet radiation in the ozone layer. So it contains 90% of the atmospheric ozone. Very important. 90% of this layer, stratospheric ozone. And beneficial zone, what is the benefit of it? Act as a primary ultraviolet radiation shield. So it provide a shield, okay, and all the ultraviolet radiation which reaches to the Earth's surface, this is the stratosphere layer. And above this region there is a presence of ozone layer. So this is a part of this ozone layer is a part of the stratosphere layer, and it contains around 90% of the ozone, right? So what happened when the radiations reaches to it, along that they are having ultraviolet radiations. So these radiations do not allow to cross this ozone layer. It is either reflected back here. It do not allow to cross the ozone layer and reaches to the Earth's surface. Okay. Now there are some current issues, long-term global downward trends and springtime Antarctic ozone hole each year. So we can see some of the ozone hole because thinning of the ozone layer. Now why this ozone layer is thinning, this is another topic we can discuss there, but we need to remember just that the ozone layer is get thinner because of some pollutant, and that pollutant comes to that level or that layer due to the pollutant released from the Earth surface, and that is anthropogenic, means by man. right? So stratospheric ozone layer is a very that contain the ozone layer, that is the very important. Now troposphere ozone is also there. We are having ozone at the tropospheric layer also. So it contains 10% of the atmospheric ozone, and here it is very harmful. When it is present in the stratosphere layer as an ozone layer, it is beneficial to the mankind. But when it is present in the troposphere, okay, it gives you a harmful impact. That is a toxic effect on the human and vegetation. Right? So current issues, episodes of the high surface ozone in the urban and the rural area. So when ozone is present in the uh, troposphere in the form of a smog, very important, in the form of a smog, then it is a pollutant. It is a pollutant. But when it is present in the stratosphere layer as an ozone layer, then it is beneficial to our environment as well as the humankind, right? Convection current is less in the stratosphere because it is warm at the top and cold at the bottom. Reverse of the troposphere. So there is also a persistent circulation pattern and high wind speeds. The upper boundary, so the upper layer is warm. Okay, upper layer is warm and the lower layer is colder. So wind is more at the higher level. So that is why it is written here. There is also persistence of circulation pattern and high wind speeds. The upper boundary of the stratosphere is called as stratopause. So here we can see stratopause. So stratosphere, this is the stratosphere, and in between the mesosphere and stratosphere there is a stratopause region. Okay, now next layer, mesosphere or ozonosphere. There is a maximum concentration of ozone between 30 to 60 kilometer above the surface of the earth, and this layer is also known as ozonosphere. So mesosphere is also known as ozonosphere because it is having the maximum concentration of ozone. Okay, ozone absorb UV rays, comes along with the sunlight. In the absence of this layer, UV rays may reach to the surface of the earth. Due to the large amount of the chemical process takes place in this sphere, it is called as chemosphere. So lot of photochemical reaction takes place in this layer. So that is why it is also called as chemosphere. Okay. Temperature of the ozonosphere is high and warm due to the selective absorption of UV radiation by the ozone layer. In this layer, the temperature increases with height at the rate of 5 degrees centigrade per kilometer. So as you move every kilometer, then there is a 5 degrees centigrade rise in temperature per kilometer. So as you move high to the mesosphere layer, the temperature rises. The upper boundary of this layer is called as mesopause. So after the mesopause, there is a thermopause, thermosphere layer, and in between the thermosphere and mesosphere, there is a mesopause. Mesopause is the coldest region in the atmosphere. Now here comes a question, that which of the following is the coldest region in the atmosphere, with temperature reaching the lowest value nearly minus 95 degrees centigrade. So that is mesopause, and it is around 80 kilometers above the earth surface. Fourth layer now, that is the thermosphere or ionosphere. The thermosphere layer lies beyond the ozonosphere or the mesosphere at a height of about 80 kilometer above the earth surface. So till 80 kilometer we are having the mesosphere, right? And there is a mesopause. Now above that layer, Okay, so there is a layer which is called as thermosphere, and it extends up to 400 kilometers. 400 kilometers. That is the thermosphere or ionosphere. The atmosphere in the ionosphere is partly ionized. Enriched ion zones exist in the form of distinct ionized layers. So this layer is also called as ionosphere. So a lot of partly ionized particles are present in this particular zone. That is why it is called as ionosphere. Above the mesosphere, the temperature increases against, and it is order of 1000 degrees centigrade. So ionosphere reflect the radio waves because of one or multiple reflections of the shortwave radio beams from the ionized shell. So this ionized shell reflect multiple reflections. It reflect multiple short waves radios beams. Okay, so long distance radio communication is possible due to this layer. Okay, beyond this layer, there is one more layer which is called as exosphere. So the outermost layer of the Earth atmosphere is named as the exosphere, and this layer lies between 400 and 1000 kilometers. So 400 to 1000 kilometer is the exosphere. Okay, so at such a great height, the density of atom in the atmosphere is extremely low, very low. Okay, the density of the atoms is very low. So the hydrogen and helium gases predominate in this outermost of this region. So mostly they are having hydrogen and helium gases in this particular region of the atmosphere. So at an altitude of about 500 to 600 kilometer, the density of the atmosphere becomes so low that the collision between the natural particle become extremely rare. So no photochemical phenomena takes place in this particular region, right? Okay, so this is all about the different atmospheric layer. Okay, so we will meet with one more session for the agrometrology. Okay, thank you very much.